Hi guys, I'm gonna make a video about 7.1. We finally get sort of back to what you would have been familiar with coming right from calculus. Um, Although some of the problems are quite technical and they're specific. So um, after 7.1 to 7.2, we'll be starting chapter 8 right after test 1. And that should be a little more smooth. So I hope that the class sort of gets a little better. I'm sure you guys have been challenged quite a bit with the chapter 6 material. And some of you have asked me about practicing U sub because we've used it a lot. So I'll try to incorporate some of that into chapter 8. Okay, let's jump right in. Also, guys, just like from my teaching style, when we get into chapter 8, I'll be more out of the book because there's a lot of stuff in there. But for these problems from 6 and 7, they're so specific. I kind of just wanted to jump into the homework. So I hope you guys are able to follow these. So we're going to start with question 9 in 6.5 to 7.2 homework. Let's get a similar question here. Now, you guys probably know how to do this one already. Um, so there's a lot going on here. We have a derivative, right? Um, we don't really do a lot of derivatives in Calc 2. It's mostly integration. So this is one of the few times we did use it for arc length, but then we integrated anyway. So this is one of the few problems where we don't use integration. So sort of back to the past with uh, Calc 1, right? So let's just talk about what you need to know from Calc 1 to do this problem. You're going to need to know the product rule. Okay, so make sure you know that. And that said, when you take the derivative of two functions, f and g, all right, that's the derivative sign. The derivative of both of them is f prime g plus, now it doesn't matter what order, right? I'll put g prime f or f g prime, but that's that. Okay, so you need to know that. We're going to use that here. What else? We need to know chain rule, right? So let's practice chain rule. If we were taking the derivative of just this, we do the outer one first. In this case, it's natural log. Okay, so the natural log function says when you take the derivative of it, it's going to be 1 over whatever's inside. But then the chain rule part is you also have to multiply by the derivative of that thing. So what's the derivative of x to the 8th? It's going to be 8 times 8 x to the 7th. So what we get here is 8x to the 7th over x to the 8th. That cancels, leaves us with 8 over x. Now, this is not the answer, right? Because we're only doing part of this one. We have to do the product rule, but you need to know this, the chain rule, in order to take the derivative of this, okay? So maybe, let's keep going. Let's do this whole one. So now we take the derivative, and I'm going to point something out after this problem. I just remembered. Take the derivative of this. We're going to think of this as like our f, right, from the product rule, and this is like our g. So let's separate them like that, just so we recognize that this is one thing, and this is the other. So the derivative of x is just 1. So it's 1 times the other function plus um, x times the derivative of the other function, which we just did, and we got 8 over x. So I'm kind of skipping this because we just did this one, but you can go back and check. When you take the derivative of ln x to the 8th, we just got this, 8 over x. So this is equal to the derivative of that. And we get rid of the 1. And maybe we'll bring the 8 down front, right? Because if we have an exponent inside our natural log, it come out. The x's cancel, and we're left with just this as our answer, okay? All right, now before I move on, I want to show you guys something that's important in the course. So one of your students was doing student hours with me, and they reminded me that we have in our class, if you go to, if you open Pearson from the Access Pearson and you're in Pearson, you'll see this tab. if you just go through Canvas and click the homework, you won't be able to see this. So make sure that you're using Access Pearson. And then when you're in there, click Video and Resource Library, and voila, you have a student solution manual included with the course. So something I want you guys to use for the rest of the class is the student solution manual. So we are in chapter 7, but you can use it for chapter 6 and chapter 8 when we're in that. And you might find it very helpful. So make sure you guys are using this. It has all the odd solutions. So you just look for a problem that's like the one you're working on and see it worked out. Okay, and I think it'll help a lot. In fact, right here, if you can see this one, we're going to use this technique in the next problem, okay, or the next one or two after. Anyways, make sure you guys are using that. Back here to assignments. Okay. So, go back to this one. It was 9, I think. Yeah, it's around 10. Now, you guys do have the view and example, so make sure you're using that too as you work through these problems. This is a great problem, honestly, but it's not easy. But if you're really good at this stuff, you could probably do this in your head. And I know it sounds far-fetched, but you can. This is chain rule. We have a nested function, meaning there's a log inside a log. And then inside that log is the 14x. So we already know that if we were just asked to take the derivative, which this is, of ln 14x, and you can check this, we would get 14 over x. I believe, is that right? Let's see, 1 over 14x. Nope, sorry, that's not right. We would get, let's look at that part. We would get this. 1 over 14x times the derivative of 14x, which is 14. So the 14's cancel. So it's just 1 over x. Okay, so the 14 doesn't really matter here, but it actually will be in the answer. Why? Because if we use chain rule, so step by step, I think you guys can kind of follow. First, we do the derivative of that, which says do 1 over whatever's inside it. What's inside it is that. Okay, times chain rule part, the derivative of the inside. So what's the derivative of ln of 14x? It's 1 over 14x times the derivative of the 14x, which is 14. So you can see these 14s will cancel and we get 1 over x times ln of 14x. That's the answer. Okay. So hopefully that's not too bad, but practice that, right? If you get it right, do the question over. Now, I actually got these next two right when I did them, but I didn't write them how the book wanted. So I'll kind of show you that. This is a very, very, very specific problem. I would not ask this on an exam, but the last ones I've did, as well as ArcLink, you can expect to be tested on for test one. So this is very specific. There's probably ways that the book has to do this, but the way they show is, I don't think, a very good way, but we're just going to do it. And again, it's just one of these problems we're just going to do and forget about. So how the book does it is they say, now these are old rules, right? So when you write something like this, e to the ln x, you have to remember that that's the same as x. So what we're going to do is we're going to write this as e to the ln of, we're going to call this like our x or u. And I know people are already like, what is this, right? But we do that. Now, why? I don't know. But what we can do, because really interested in this part, we can write that as e to the 6x. And I'm directly copying how the book does this. So this is not my idea. And then we know that when we take the derivative of e to the u, derivative of e to the u, we get e to the u du. In other words, we get the same thing we had times the derivative of whatever's up there. So we're going to treat this whole thing up here like a u. So we're going to say u is, so we're kind of back in Calc 1, aren't we? ln 2x. Now, this is product rule. So we take the derivative of this. The derivative of 6x is 6 times the other thing. Remember fg prime whatever plus 6x times the derivative of this, which is 1 over 2x. So we got 6 ln 2x. 6x over 2x is just plus 3. Right, 6x over 2x. Now that's a little messy. That's our du. And so the answer is just e. Now watch this. This is sort of hand waving. So watch how we get this. Put parentheses here. Times du, which is this in the box. So 6 ln 2x plus 3. Now over here, we can rewrite this as this. E to the, which is what we originally had, right? Yeah. ln 2x, 2 or more, 2x to the 6x. But the e and the ln cancel, so that this part gets multiplied by the du. Okay. So that's the answer. It'd be 2x to the 6. I don't keep writing it there. 2x, another one. 2x to the 6x times 6 ln 2x plus 3. Okay. So that's that one. The next one is a little worse. It's a little bit worse than this. So I believe this is the last one from 7-1. So we're almost, oh, no, we have that one too. This is also a good problem, but let's do this first. Okay. A lot going on here, right? I'm going to work this straight through and show you that if Pearson will mark the correct answer wrong, it's just programmed very specific for this one. So we're going to do the same trick, but we're going to have e to the ln of this thing. So this is already, you can tell, pretty ugly, nx. So what happens because of log rules is we really have this, e to the negative ln 10x. This thing comes down times the ln of 10x that's up here. Okay. So we have the same situation. We have our e to the u, and then we have to find du, which this is our u. So if that's our u, by applying product rule, we can get du. So du, let's see, the derivative of this is negative 1 over 10x times 10. That's really negative 1 over x times this. So it's ln 10x over x with a negative. Let me rewrite it so it's more easy to follow. So we get that. So that's by using this as the first function times this thing and plus, but it's really going to be minus. Let's make sure we have a minus sign here too. Minus the derivative of this, which is 1 over 10x times x. So it's just 1 over x. So let's just write that. Right? You take the derivative of that guy, you get 1 over 10x times the derivative of 10x, which is 10. So it's 1 over x. So it's 1 over x times this function, which is, so it's negative this, negative ln 10x over x. Now I'm going to leave it like that. Watch what Pearson does. So let's erase some of this. So our answer is e to the u, which is what we had, times du, which is this. So it's really this. If I enter that, well, by the way, this e cancels, right? Well, let's look at this one. So this is the same thing as this. these e's cancel, this e and ln cancel. So we really have 10x to the negative ln 10x, which is the original thing. So we really have that times du. Okay, so let's just write that. So we have that 10x to the negative ln 10x, and Pearson will mark this wrong. So that's the e to the u part, but the e and the ln cancel, so it's really just u times negative ln 10x over x minus ln. So I just want to show you guys this because you might actually have the right answer, in which case on the exam you get full credit. Let me erase this so you can see it. So this is the answer I'm giving to Pearson, which is right. Okay. Let's check it. It's going to mark us wrong. Oh, this time it marked us right. Okay. Anyways, the actual answer it showed me before was different. It looked like it wanted us to combine these two and write them as 2 times that, and then cancel stuff. But anyways, that's good that it worked. So makes me look really smart. Haha. All right, let's go on to 13. This is a really specific problem, and I'm also teaching a differential equations course this semester, and these type of integrals actually show up. And what I mean is, right, because of where we're at in the course, um, we only know u substitution or power. We don't have anything else. Okay, so there's not a lot we can do at this point. So the way I'm going to show you, and I believe Pearson will do something slightly different, but I'm gonna keep it pretty simple. So watch this. And you're welcome to do what Pearson does as well. But let me show you this. If you follow it, great. So what we're going to do is we're going to separate this as 2 integrals. One with the 2x over x plus 1, and one with the 1 over x plus 1. This one we can do. This is a u sub where u is x plus 1, and the integral of that is going to be ln of x plus 1. So this is just ln x plus 1. Make sure you evaluate it from 0 to 4. Okay, so it's really just going to be ln 5. All right. This one, I'm making this up, but this is kind of a tricky way to do this. So I can write 2x as x plus x over x plus 1. And then I could split that into 2 integrals like I did this, right? So we really are turning this whole problem into 3 integrals. Now, the nice thing is, once I figure out how to do the first one, the other one's identical. So I really am just doing one integral and doubling it. Okay. Sorry. Okay. This is a u sub, but it's not an obvious u sub. So watch this. I'm just going to do this one up here, but you're going to have to do the same thing for this. Don't forget to do both. What I do is I let u equal x plus 1. Okay, so du is just dx. Now I notice that I have an x up here. So let me try to write this part by itself so you guys follow. So we have u is x plus 1. The integral we had was x over x plus 1. What we do is we say, well, that's really x over u plus 1 du. But we notice from here, it's a sort of a backwards move that u minus 1 equals x, just doing algebra. So I can substitute this as x. And you probably lost, but that's okay. Just watch this. Okay. Sorry, it's not u plus 1, it's u. So it's just u. That's the key. Because x plus 1 is u. So we have that. Now what we have, again, we can split this into 2 integrals. This is u over u minus 1 over u. This is just integral of 1. This is integral of 1 over u. Okay, so let's do the whole problem. Right, we did this. We did this one by itself, far right one. Okay, so 4. That's going to be ln of x plus 1 from 0 to 4. We're doubling this integral. So we can just think of this as 2 times integral of x over x plus 1, which using a u substitution we said was 2 integral u minus 1, where u is x plus 1, over u, which is 2 times the antiderivative from 0 to 4 of 1, minus, sorry, undo, minus the antiderivative of 1 over u, plus this one. So this is what we get to. These are all from 0 to 4. It's also 2 times this one, sorry. So let's leave that part and let's show what that simplifies to. Okay, like hopefully this video helps. You obviously have you an example to follow. They're going to do some variation of what I'm doing. Okay, so antiderivative of let's do this one. That's just 2. What's the antiderivative of 1 dx? Just x from 0 to 4. Minus 2 natural log of u, but we said u is x plus 1 from 0 to 4, plus natural log of x plus 1 from 0 to 4. If we simplify that, so you can see it from start to finish. But remember, now you know you have the student solution manual. Go in that, find a similar problem, and practice what the book does. I guarantee you it's this technique. All right. 2x from 0 to 4, that says do 2 times 4 minus 0, because our function is x. Minus 2 times, when you plug in 4, you get 5. When you plug in 0, you get 1. But natural log of 1 is 0. Same thing here. Natural log of 5 minus natural log of 1, which is 0. And whatever this simplifies to is the answer. It looks like it would be 8 minus 2 ln 5 plus ln 5. So it would be 8 minus ln 5, because you have 2 of these and 1 of these, so it's minus 1. All right. So again, I hope this video helps. I'm going to make oh, we have one more. Sorry, one more. Let's do this one. This is how I do this one. Sort of making up my own technique. You could find the formula in the back, but it's not too hard to derive yourself. So let's just do it. You may or may not know. So this is what it all hinges on. It goes back to Calc 1. Do you know what you get when you take the derivative of some number raised to the x base? Now, normally we think e to the x, you know, derivative of that is itself. The reason it's itself is because we're actually doing this. It's e to the x times ln of the base, but ln of e is just 1, so we always end up with this. We have a base other than e, in this case 5. I know that the derivative of a to the x is a to the x, the thing itself, just like this, times the natural log of the base. When it's not e, we have something left over. So let's just plug that in. So when we take the derivative, now watch this. This is kind of fundamental theorem of calculus. D over dx, 5 to the x, we would get 5 to the x times ln 5. Now, since I know that when I take antiderivatives, I would get rid of this, right? So watch this. Give myself more space to write in. Okay. So what I'm going to do is I'm going to take the antiderivative of both sides here. So take the antiderivative of this. So I hope you guys follow this part. Now the key thing is here, just like ln and e will cancel, antiderivative integral sign and d over dx are opposite, so they cancel. So watch the magic here. You can kind of figure these things out for yourself, but I'm just taking the antiderivative of both sides of this. Now I know that they have endpoints here, limits to plug in, but whatever. What happens here is this cancels. So I get 5 to the x is antiderivative 5 to the x ln 5. You're like, well, how does that help us? Well, wait, wait for the magic. No. So how that helps us is make sure everything's visible here. Okay. We have a problem involving 5, the antiderivative of 5 to the x. So we don't want this ln5 here. We move it over. So what this tells me is that 5 to the x over ln5 is equal to the antiderivative of 5 to the x. So I've basically solved this integral because what I've done is say, well, when you take the antiderivative of 5 to the x, you're going to get 5 to the x over over ln5. We just have to plug in the endpoints. Okay, so you see that trick? So I'm using sort of reverse calculus, right? Reverse derivative to get type derivative. And then you plug in, right? So it's going to be 1 over ln5 times, or of 5, plug in 2, the exponent, minus -2. And you can actually type that as your answer, and it'll be right. Okay. All right, so that is 7.1. And we have a couple more to do with 7.2, nothing. All right, so that's really it, guys. So I took out the 7.2 stuff because it's not really in the syllabus. We don't really have to do it. Um, I didn't like how the book started this. It's the first time I'm using this book, so I'm kind of learning it. But be ready for chapter 8. That's where the real Calc 2 is going to start. The homeworks will be a little more spread out, so I won't have them grouped like they were here. Although I'll have an 8.1 by itself, an 8.2, and it should be a little better. So that's it. If you found the video helpful, let me know. Thanks.